Okay, here we are with an HL definition-based question. If you are an SL student, feel free to skip this one. HL, watch on to see an explanation of the answer. Okay, this is a very rare kind of question you get, but it's a nice one to get, all about definitions. We're looking at the work done per unit mass in moving from infinity to point P, and we're trying to link that to one of the four quantities. Now, they're all very similar. We've got field strength, force, potential energy, and potential. Now, hopefully you're aware of the difference between these. What I'm going to do excuse me, is go through these, really just an opportunity to revise some definitions, and then we'll look at what the answer is. We'll start with gravitational field strength. Now, I've put this up here. We've got a body, or assume we're a spherical body of mass m. Gravitational field strength is gm over r squared, and the units of that are newtons per kilogram. What that means in terms of a definition is we're looking at force per unit mass. So that is not the definition we are looking for. If we then go into gravitational force, well, hopefully we're aware that that comes from Newton's law of gravitation, gmm over r squared. Okay, and the units there are newtons. Again, that's not what we're looking for, because we're looking for something with the units of work done per unit mass. You could have a think about that. We're looking at work done, joules per unit mass per kilogram. We've then got gravitational potential energy. Now that is a slightly less sort of known equation. It's very similar to the ones you've got up here. Potential energy is G times M over R, and its units are joules. So you can see we're getting closer to what we want, work per unit mass. However, we don't have that unit mass element. That's because the answer is G. G is the gravitational potential. It's given by Gm over R, okay, and we've got this joules per kilogram, and that is why our answer here is D.